Alrighty, y'all. So let's talk about how we can write the end behavior of our polynomial functions. So just a reminder about end behavior. End behavior is the description of the y values of a function as x approaches positive or negative infinity. So when we're looking at our polynomials, we'll talk about this in a later video, but we're going to look at the degree and the leading coefficient to determine the end behavior. And here's what we're going to key in on this video, how to actually write it. So this first method is writing it as a limit. Y'all are going to see this in pre-cal and calculus, and we're going to read this as the limit of f of x, so f of x just being our polynomial that we're looking at, as x approaches infinity. So now that is telling us, hey, on your graph, go as x approaches infinity, so look to the right and tell me what's happening to your y values. And then similarly, we could also write it as x approaches infinity, f of x approaches, and then you're just telling me what's happening to the y values of your graph. And then on the left, it's very similar, but now we're saying the limit of f of x as x approaches negative infinity, which says, hey, look to the left of your graph, tell me what the graph is doing, tell me what the y values are doing, and then we could also write it as x approaches negative infinity, f of x does what? So let's look at an example really quick. We're going to write the end behavior. So for this first one, I'm looking at this function. If I'm writing as x approaches infinity, so as I go to the right of my function, what is my graph doing? Well, it's going up and up and up and up and up forever. The y values are increasing to infinity, so I'm going to write that as x approaches positive infinity. H of x also goes to infinity. Again, this h of x approaches is telling you what the y values are doing to the right of the graph. Now we're going to look at the left of the graph. I'm like, hey, I'm going to the left, so I'm going to say as x approaches negative infinity, f of x, or the y's of my function, they're going down forever. So this is how I'm going to write it. As x goes to the left to negative infinity, my y values are decreasing as well to negative infinity. So one more, this guy we're going to write as a limit. Same idea. So I go to the right of my graph to positive infinity, my y values are decreasing to negative infinity. So here's how we're going to write it. The limit of q of x as x approaches infinity is equal to negative infinity. So here you're just dropping in what's happening at the end of that graph. Similarly, we can look to the left of our graph. It is approaching negative infinity, and my y values are going down. So I'm also going to say that is equal to negative infinity. So those are the two ways to write your limits or your end behavior. Again, we don't care about all this mess that's happening in between. Could care less. I just want to know what's happening at the endpoint.